In this video, I'll be working through the question you see on the screen from the Mechanics paper 4.2 from the Cambridge A-level exams from 2023. I'll be doing this on the board, hopefully just like you're used to your teacher doing in a classroom. If you want any other questions from this paper, you should be able to find a link to the playlist in the description below. And if you find any of my videos useful, I'd greatly appreciate if you subscribe, or if you think any of your friends might find it useful, please go ahead and share it. In question 2, they describe a system where two balls or two masses, two particles, are traveling on a table. One of them, A, is going this direction, the other, B, is going this direction. They're going to collide with each other. Let's see, we have some masses here, 3.2 and 2.4, and they have, it's a little complicated how they describe it. They say A moved towards B with a velocity of v, and they say it collides, and B, which is moving towards A. So if your English is not perfect, I think some students may have missed some of these numbers, which is unfortunate because maths shouldn't really be about the English. Anyway, this is the system they described. Ball A is going this direction, ball B is going that direction. They collide and they tell us that they come to a rest. After the collision, they just stop moving. They're, let's see, state 2 would look like this. They're just right beside each other. Okay, how do we solve this question? The simplest way here, actually the only way that I can see, would be, we can't really use energy because, as we find out, it's not a perfect collision. They tell us in part B there's energy lost in that collision. So we can't use energy because we don't know a velocity at the start and we don't know what's lost. So we can't use just energy right now. So we'd have to use conservation of momentum. We know the momentum of ball A. Momentum P is equal to mass times velocity. So that's momentum of A. We know the momentum of, let's say, PA. PB is equal to, what have we got here? 2.4 times 6. If we then combine their momentums, this guy will say is positive, this guy is negative, or doesn't matter which you turn negative, they're acting against each other. So we'd say 3.2 V minus, what's this, 12 plus 14.4. And that has to equal the momentum of both of them together. So the two masses, 3.2 plus 2.4 multiplied by the velocity, 0. So you could just write 0 there, it's okay. So let's go ahead and try to solve this. We get phi on its own. Phi is equal, let's add that to both sides, 14.4, divide 3.2 from both sides, 3.2, and we would get, let's see, 4.5 meters per second. So V up here is 4.5 meters per second. Okay, that answers part A. In part B, they ask us to find the loss of kinetic energy of the system due to that collision. So I said before we couldn't use energy to solve this because we were missing too much. We didn't know the loss of the energy from the system and we didn't know the starting energy from the velocity. Now we do, we solved the velocity. So now we know how much energy goes into the system. We're going to find out how much energy goes in. We're going to find how much energy comes out of the system, or at the end of the system, and we're going to find out what's missing. So again, let's do this as two states. State 1 is this image, state 2 is that image. State 1, let's split it up like this. State 2, the energy at the start of the system is, there's no potential energy from either of them, so it's two kinetic energies. So it's a half m, a 3.2, 4.5 squared. And this guy, even though they're going opposite directions, we don't have to put a minus here because it's energy being added into the system. It's So this energy is positive and this energy is positive. In fact, you won't be dealing with negative energies until you go to graduate schools or something. Sorry, the energy, so the kinetic energy from this guy is here. Kinetic energy from this guy is a half, I don't really have much room, but 2.4 times 6 squared. And the energy at the end of the system, I don't need nearly this much room because there is no energy. They're not moving. They're on the ground. There's no potential energy. There's no kinetic energy. The energy is 0. If I add this one up, I get 75.6. Just put all that in a calculator. So there's 75.6 joules at the start of the system. There's 0 joules at the end of the system. Something happened. There was a loss of energy here, and that's from this collision. So I guess you could write something like let's see, loss of kinetic energy from the system. Energy lost, I would write something like energy lost 75.6 joules. That's the answer to part 2. If you have any questions, let me know in the comments below. I'll do my best to answer. Thanks for watching and have a great day.